Hello students, welcome back to computer science classes of class 12. Today we are going to start with the next portion of computer networks. Let us see what are the different topics that we are going to cover in this session. We are going to learn about OSI layer and then the network devices. Let us see what is OSI layer. It stands for Open Systems Interconnection Model, and it is a conceptual model that characterizes and standardizes the communication functions. Basically, it divides the whole system of networking in 7 layers. Let us see what are the different 7 layers that we have. Starting with physical layer. Interestingly, the whole thing is just reversed one. At the bottom we have got physical layer, that is the first layer. Then we have got data link layer, after that network layer, then transport layer, then session layer, presentation layer and application layer. Let us understand what is happening in all these layers. First, the physical layer, it sends the data to the physical wire. Then in the data link layer, it reads the MAC address, that is the physical address, from the data packet. And then in the network layer, it reads the IP address from the packet. After that, in the fourth layer, that is the transport layer, which is responsible for transporting of protocol and error handling. Is there any error or not, that is to be checked in the fourth layer, that is the transport layer. And in the fifth layer, the establishes and end connections between two hosts. In the sixth layer, that is presentation, where formats the data so that it can be viewed by the user, that is encryption or decryption. And in the last layer, that is the application layer, in which all the services that we have is provided to the end users, like your email. Okay. So now we are going to learn what are the different devices, different network devices that we can use in different layers of OSI. Let us have a look. In the physical layer, we can have hubs, repeaters, cables, the fiber optic cables or any wireless medium that can be used in physical layer. In the data link layer, we will be using bridges, modems, network cards, two-layer switches. Okay. In the network layer, we can use routers and the three-layer switches. After that, in transport layer, we can use gateways and firewalls. In session layer, again gateways, firewalls and your PCs, the portable, your personal computer. In the presentation layer, same as session layer. And in the application layer, you can use all other end devices like phones, servers, your smartphones. Okay. I hope this is clear to you all. This portion is very important. Now, let us start with one by one the network devices, starting with modem. It stands for modulator and demodulator. A modem is a computer peripheral that allows you to connect and communicate with other computers via telephone lines. And the basic goal of modulation and demodulation is to produce a signal that can be transmitted easily and decoded to reproduce the original digital data. So, modulation is actually what? It is encoding, and demodulation is decoding. So, the plain text is converted to the ciphertext, that is the modulation, and then the modulation, in the demodulation, the ciphertext is converted to plain text. So, this is actually done and expressed in bits per second, that is the BPS, or sometimes bytes per second, that is, you can see over here. We can also say it modulates an analog carrier signal to encode digital information and also demodulates such a carrier signal to decode the transmitted information that I have already explained. So you can see in the diagram from the PC, the digital information is being converted to an analog signal, and then again it is converted to the from here from the PC it is converted to the signal, and from the signal it is converted to the analog one with the help of telephone lines, or in the opposite direction if you say the analog is converted, the analog one is converted to the digital one with the help of the modem. So it is actually converting the, sorry for the interrupt. Yes, let's get started. Yeah, so it is actually converting the analog to digital and digital to analog. Hope the modem is clear to you all. Next we have got RJ45 connector. This cable you must have seen in your computer lab. This RJ45 connector is short form for registered jack 45. It's an 8-wired connector that is used to connect computers on a LAN, and specially we call it as Ethernet. It looks like an RJ11 connector used to connect telephone equipment, but they are somewhat wider. You can just see the pictures. Now moving to Ethernet card. An Ethernet card is kind of network adapter, or you can say network interface card. These adapters support Ethernet standard for high speed via cables, and it also connects connections for either coaxial or twisted pair cables and even the fiber optics, basically the wired one. You can see the example, you can see the photograph of Ethernet card. It does not looks like a cable or wire. Now though they look similar to boxes, but they are actually USB Ethernet adapters. Now Ethernet cards may operate at different network speeds depending upon their protocols. Now old Ethernet cards, they can operate till maximum of 10 Mbps, whereas the modern one can work with up to 100 Mbps. So faster the Ethernet standards are always available up to 1 Gbps. Nowadays it is coming with this. Now moving to repeater. A repeater operates at physical layer, and its job is to regenerate the signal over the same network. So repeat, when we say repeater, what it means? Suppose I have got some information from someone and I have to deliver to other person. So what I am going to do, I am going to amplify the amount of frequency and then again give it. But suppose I do not have any repeater, I have just thrown my message and in between no repeater is there. How long it will be going? In between means in between only it will just lost, right? So we require a repeater for longer transformation of the information. Yeah, it's an important point to be noted about repeaters is that they do not amplify, they just repeat it, okay? When the signal becomes weak, they copy the signal bit by bit and regenerate its original strength. It is also known as a two-port device because it is single input and single output. Now moving to hub. Hub we can call it as multi-port repeater. A hub connects multiple wires coming from different branches. For example, the connector is a star in a star topology which connects different stations. So hubs cannot, one more important thing, hubs cannot filter any data. So data packets are sent to all connected devices. It cannot identify that this data is to be sent only this particular destination. I do not have to send it to everyone. So this intelligence is not there with hub. Okay. Now let us see the different types of hubs. First is active hub. These are hubs which have their own power supply and can clean, boost and relay the signal along with the network. It also serves as repeater as well as wiring center. On the other hand, passive hub, these are the hubs which collect wiring from nodes and power supply from the active hub. So these hubs relay signals onto the network without cleaning, without boosting, and cannot be used to extend the distance between the nodes. So I hope the difference between active and the passive hub you have understood. If we summarize the whole portion of hub, you can say a hub connects multiple devices to share resources and transfers data at physical layer. So it is working in the physical layer of the OSI model. It is also known as multi-port repeater. I hope all of you have understood why we are calling it as multi-port repeater. Then hubs are not intelligent, hence they cannot forward data on a particular destination address. It cannot identify, okay, the logical and physical addresses. There are types of hubs. We can have active hub, which can regenerate, monitor and amplify signal. It needs electricity. And passive, it cannot regenerate, cannot monitor, cannot amplify. So no need of electricity. There is one type of hub, that is intelligence hub, which monitor network traffic and can configure each port on it individually, and that is also known as manageable hub. So this is an important one. Now after that we have got switch. A switch is a device. It similarly works as your hub, but there is a very minute difference with hub and switch. Switch has got the intelligence, as that is not there in the hub. Okay, it prevents the traffic overloading. It allows different nodes of a network to communicate directly one another. Okay, so this is very important, and it works in your data link layer. It is not working in the physical layer, whereas hub is working in the physical layer. Now let us have the difference. Hub repeats the incoming traffic to all connections, whereas switch sends the traffic only to appropriate connections, appropriate destination. So that's why it's intelligent. Hub offers single lane connection and hence either send or receive, but switch establishes two-lane communication. So it can facilitate sending as well as receiving at the same time. Hub shares bandwidth with all the connections, whereas switch does not share. It has specific bandwidth for each and every connection. Hub is not that expensive. Switch is expensive. Obviously, switch is having so many facilities, so it is expensive other than the hub. Let us understand what this bridge is doing. Bridge operates in the data link layer as the switch is working. It is again a repeater with add-on to functionalities of filtering content by reading the MAC addresses of source and destination, that is the physical address. It is also used for interconnecting two different LANs working on the same protocol. It has single input and single output, that's why it is called as two-port device. So any device which is called as two-port, that means it has got single input and single output port. Okay, now let us understand the types of bridges. We have got transparent bridges and the source routing bridges. What do you mean by transparent bridges? Here the stations are completely unaware of bridge's existence. These bridges make us two processes, bridge forwarding and bridge learning. So these transparent bridges, basically suppose we have got a network. We have got a network over here, and in between there is a bridge. None of them knows that there is a bridge. They are completely unaware of the existence of bridge. Then that time it is transparent bridge. But in source routing bridge, the routing operation is performed by the source station, and the frame specifies the route to flow. So that's why we call it as source routing bridges. Hope this is clear to you all. Next we have got routers. Routers is again similar to bridge. You can just see everything is almost interrelated to each other, right? But there is minute difference with each other. So that difference you have to keep it in mind. Like here, bridge is working how it is working. It can connect two different LANs of the same protocol. But router, again we are saying, is working similar to bridge. But what is the difference? The difference is router can handle different protocols. Bridge can handle similar types of protocols and connect two different LANs. Okay, but router can handle different protocols, and it is working in network layer. When it is saying that it can handle different protocols, so it have to understand that it is in the network layer, whereas the bridge is in data link layer. So the routers normally connect LANs and WANs together and have a dynamic updating routing table. Routing table is not in the syllabus. We will be discussing in the later half. And router divide broadcast domains of host connected through it. So router is very important as compared to your bridges. Now moving to gateway. Gateway, that it is dissimilar as what it does. It connects the dissimilar networks, and it works in the 6th and the 7th layer, that is the session layer and the application layer. And very rarely it also works in the network layer. So it is a passage to connect two networks together that may work upon different in networking models only. Like someone is working in peer-to-peer architecture and someone is working in the client-server architecture. So they basically work as the messenger agents that take data from one system, interpret it and transfer it to the another system. So it works as a very important role. It also called protocol converters because it can operate at the network layer and it can convert the protocol from one to another. So it is very, very, very complex as compared to switch or router or your bridge. Now next we have got router. This is very interesting. Router is actually a combination of bridge and router. We can also call it as bridging router. Okay, it combines both the features of bridge and router. When we can say it is combination, so it can also work either in the data link layer or in the network layer. Okay, so working as router, it is capable of routing packets across the networks, and working as bridge, it is capable of filtering the LAN traffic. So it has got both the positive features of the router and the bridge. With this, we are over with the network devices. I hope the session was fruitful and enjoying. If you have any doubt, do contact me. We'll explain. Thank you.